Hey guys, welcome to day 3 of linear programming. To start us off, Eden D from 3rd period emailed me not 1 but 2 math memes for today. So remember, if you send me math memes, I will put you on the screen, right? I think yesterday Peyton got a crown, so I think Eden's going to get, instead of a crown, I'm going to give her like a little cape. Like she's Super Eden and she's flying in the sky, right? She's awesome. Okay, here we go. First one, me, I'm sad. Them, then turn it into something positive. Me, absolute value, I'm sad. Look at how savvy we are, because absolute value always makes it positive. And then what happened to the plant in math class? Well, it grew square roots, not just regular plant roots, but square roots, right? It has to be geometric in math class. Okay, let's do some linear programming. So yesterday we just did one problem, the stamp problem. Today I'm just going over one problem for day 3. It's like a furniture problem. And this is just optional extra practice. You don't have to watch this. Right now your only assignment should be your take-home test. Okay. There is some optional extra homework practice in the assignment sheet, but that's just if you want to do extra practice. If you want to look at other examples and work in the worked out key, you have that as a resource. Okay, so let's just talk through how to tackle this kind of a problem. So Kim wants to replace some furniture in her restaurant. She has $6,000 to spend. I'm going to change Kim's name. Kim is just some random name. I'm going to make this Teague from 3rd period is teaming up with Olivia from 3rd period, and they are starting a restaurant. So they need some furniture for their restaurant. They have $6,000 to spend. And let's get some other info. Tables cost $120, and that's also a cost. I'm going to highlight that all yellow. Tables are $120, chairs are $75. And then she would replace no more than 4 chairs for each table she replaces. So what that's just kind of getting at is, like, if you have a table, let's say she has normally 4 chairs, right? We're assuming that if she's replacing, like, the chairs because they're old, right, she's not going to replace more than 4, right, because there's 4 chairs for each table. Some of the tables might have, like, 1 bad chair or 2 bad chairs, so they might not need to replace all 4 of them, just the ones that are older or broken. So that's just kind of what that reasoning might be. We're going to call X the number of tables she replaces and Y the number of chairs she replaces. So remember our objective function is all about money. So in the description, the yellow clues I got were money. So my profit based on X and Y is going to be, tables are 120 and tables are X. So 120 times X plus 75 times Y. And this actually, if I'm looking here, like the optimal solution, it's not actually going to be profit, it's actually going to be cost. So apologies. Because this is like looking for what's the minimum amount of money we have to spend, right? I'm assuming, like, if I'm looking at all this, right, they want to replace furniture, tables are that much, and such. I'm assuming, like, we're looking for the minimum amount that she might have to spend, as well as maybe the maximum, right? Typically they should say what they're asking you to find. You can kind of typically guess as well. Your take-home test will be very clear. You'll get like one problem like this and you'll do the work so I can see that you know the process. Okay, and defining our variables, that's already been done up ahead. Okay, we want our inequalities. So let's see, I know that the number of chairs, which is X, has to be bigger than 0 or equal to, right? Y could be bigger than or equal to 0. And then what else do we need to do? We need to incorporate the 4 chairs for each table idea, right? So let's think through that. And actually, before we look at the green clue, because the green clue is pretty tricky, we also should think through that in addition to the objective function telling us, like, the cost, we also have to use that 6,000 in some way. That's going to be a third constraint. That, let's see. Let's incorporate that. So the amount of money that she spends, which is going to be represented by 120x plus 75y, that has to be less than or equal to 6,000. Okay, so that's all kind of money clues. The last one is she would replace no more than 4 chairs for each table she replaces. So what I'm going to do is I'm first just going to use chairs and tables, and then I'll put x's and y's later because it's a little easier. Okay, so if you think through, to get the number of chairs would equal, like, if we pretend that we always have to have 4, let's just pretend that we need 4 chairs per table. The question is, do you do like 4c equals t or c equals 4t, right? Which one do you do times 4? The first equation is saying 4 times the number of chairs equals the number of tables, and that doesn't really make so much sense. It is true, though, that the amount of chairs we need is however many tables there are times 4, because there are 4 chairs at every table. So we're going to start off with, like, chairs equals 4 times the number of tables, right? But then it does clarify that she might not need exactly 4 for every table. Maybe some of them, only 2 need to be replaced. So we're going to say it could equal that, or it might be a little bit smaller. So I'm going to switch it to less than or equal to. And now at this point that we have the right inequality, I'm going to put my, instead of C, that's chairs. Chairs is represented by Y. And T for tables, tables is represented by X. So I'm just putting those back in just so I don't get confused or anything. Okay. Okay. So I've got my 4 objective functions, right? And now I need to put number of tables, right, for my axes, number of chairs. Now I'm looking at my equations. The only one that's really going to give me some trouble is getting this one, the bigger yellow, into slope-intercept form, right? So I know 75y is less than or equal to negative 120x if I just subtract 120 on both sides, plus 6,000. You could also rewrite it with an equal sign as you do your work if that's easier for you. Okay, then I'm going to divide both sides by 75. Divide by 75. Remember, you have to do that on each piece. So y is less than or equal to, on my calculator, I'm going to do 120 divided by 75. And it's a decimal. I'm going to do MathFrak on my calculator, and it tells me that it's 8/5, negative 8/5, x plus 6,000 divided by 75. Plus 80. So that comes out nicely. Just a quick reminder, I'll put it maybe over here on the side, to use MathFrak, right? If you want to convert a decimal to a fraction. Okay, so I've got that equation. If I need my y-intercept to be at 80, then the only other number I know is just the slope of 4, right? That's not so bad. So let's try and think through a nice number. If I want to get like a nice visual on my graph, I could make it go up by tens, right? So this would be 10, 20, 30, 40, 50. It might be a little hard to see, right? If I do 80 divided by 5, like let's see if 5 would work. 16 high would be, because 16 times 5 is 80. So let's try 5s maybe. 5, 10, 15, 20. So this is 20. 5, 10, 15. Actually, let's go by 5. So let's go to 25. 5, 10, 15, 20, 25. 1, 2, 3, 4, 5 more boxes will get us to 50. 1, 2, 3, 4, 5 will get us to 75, right? And then 80 will be just one further. 2, 3, 4, 5. That'll be 25. 1, 2, 3, 4, 5. 2, 3, 4. And you don't have to mark every single tick mark. It's just to give some scale. So let's see. I know that I have my, x is bigger than 0 or equal to 0, right? And that y is bigger than or equal to 0. But that's just saying anything in this space. So I'm going to graph my yellow line. My y-intercept is going to be 80. And my slope is negative 8/5, so I'm going to go down 8 over 5. So 1, 2, 3, 4, 6, 7, 8 over 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. And that actually works out quite nicely. I'm going to just make that point a little bit bigger. There we go. So if I draw in my line, I'm less than or equal. So remember, less than implies it's smaller. So you can kind of start seeing that triangular region that we are going to be focusing in on. The last one I need, my last equation, is y is less than or equal to 4x. So you start at the origin, and your slope is 4. So up 4 over 1. So up 4 over 1. And it looks like it just goes shy of our graph, right? It's kind of hard to see exactly where it would hit. And since it's less than or equal to, we're going to be shading inside. So you can kind of see the region is this triangle. So that triangle is going to have 3 points, right? This point here, I'm going to call it A. Call this B. Call this C. So you can kind of guess where we might be focusing, right? So let's see, we have A, B, and C. C is 0, 0, right? That's kind of a dumb one. Of course, your minimum profit, your min profit would be, or not min profit, min amount spent might be $0 if you don't fix anything, but you have to. So the maximum amount of money that you're spending well, actually, I guess this would be like the optimal solution is like, you know, the best deal to get everything figured out. So it's like how much you would have to spend where everything is satisfied. So let's see, our B value, that is, it looks like 510. So it's going to be 50, comma 0. So that's if you got 50 X's, 50 tables and no chairs, which would be kind of weird. And our A value, it's kind of hard to see that. Remember, because our slope was 2, or excuse me, 4, we went up 4 over 1, so we've gone over 1, 2, 3 units in X. So it looks like that's X equals 3. Okay. So we're looking for where does the green one and the yellow one intersect. So where does yellow, which we can think of as -8/5 X plus 80, where does that intersect with green? And your green one is y equals 4x, right? So if you solve that like a system of equations, then you'll be able to get your final solution. It looks like it might be x is 3, but we might be a little off with our picture. Here is what you can do easily. You can use substitution. Substitute in 4x for y. So my new equation will be 4x equals -8/5 x plus 80. If I add 8/5 x on both sides, I'm going to have 4 plus 8/5. I'm just typing that in my calculator. It looks like it's about 5.6x is equal to 80 divided by 5.6. Okay, looks like x is about 14.28. So x is about 14.285. If I plug that in and do 4 times that for my y, up here we see the coordinates. So what I'm going to do is I'm going to take my 3 coordinates and I'm going to plug them into my objective function. Okay, so I'm going to pause and unpause. Okay, so I've plugged in my 3 coordinates into my objective function, and it looks like they're pretty close other than the 0. It looks like you spend a little bit less money to get just, let's see, that one is 50 tables. The other option is to do 14-ish tables and about 57-ish chairs. And it's just like a little bit more money. Now, I would be thinking through, like, you know, if you want to spend less, technically B would be the cheaper option. But it would kind of make more sense that if you have that much money to spend and you're replacing furniture, you would probably want to, you know, replace chairs and tables. So I would probably venture on that A is like your best choice based off of that. And remember, this one didn't have a specific question to answer. Okay, hope this helps with your take home.